Okay, 2.14 using proportions. Um, let's take a look at the Explorer here. What it's telling us is that there's a reality show here, and they're on an island, kind of like survival or something like that. They were given 50 cups of rice with a one scoop uh, measuring cup thing, and then bottled water for nourishment. Now, one of the guys, Evan, suggests that giving 10 cups to each person is a fair way of splitting this up. Well, most of the people said, nah, that's not a good way to do this. We should do it by a person's weight because obviously people that weigh more need more calories or what. So, in order to split it up, um, they just have the one scoop, the measuring cup, 1 cup. We are to decide that only whole cups of rice can be distributed. Now, here's the 5 players with their weights. This guy weighs that, so on and so forth. We have to find a distribution of rice that is consistent with the players' agreement. So, the best way I would go about this is I would find out how much of a cup per pound, and then that gives me a scale, sort of, the lack of a better word, to use because we definitely want, and then multiply it by how many pounds that each person has. Okay, so what I would do is find the distribution of rice. So what I want to do is cups of rice per pound, pound of weight. That's how I would do it. So I know I have 50 cups of rice. Let's see, 50, right? Yep, I'm pretty sure it was 50 cups of rice. And the total weight, well, that I would have to add 297. Get a calculator here. 297 plus 195 plus 161 plus 122 plus 105. So I have 50 cups of rice for 680 pounds total weight of everybody. Now I want a single unit of measure to get per pound. So I'm going to take my 50 cups of rice and I'm going to divide it by 680 pounds. And it's going to give me this 0.073529, whatever, cups of rice per pound. That's going to equal my single unit of measure, 0.0735 cups of rice per 1 pound of weight. Okay, that's how I would do it. For each person, using results from part A, find the ratio of cups of rice per weight of player. For each player, write down as a decimal number, which I did. Is the distribution fair? Well, let's just do one example here. So let's do an example with Alan here. So Alan is 297 pounds, and I'm going to multiply that by 0.0735, and his ration becomes, I'm just going to multiply this by his weight, 297, and gives me 21.83 cups of rice. He gets 21.8 cups of rice. So let's see, let's do another one just to compare. Becca is 195 times 0.0735. So I just want to compare and see how fair this is. 195 times 0.0735 and about 14.3. So, um, is it judging it fairly? Well, I think that's going to be a personal opinion. Um, I don't know. It all depends on your view of what's fair. I would give my opinion, but I don't want to. I don't want to, so I'm not going to. Um, then we get into what's called in statistics. We're going to get into, instead of trying to figure out, um, in this case, they're using an example of degrees, type of degrees that a population has. Obviously, it's hard or impossible to figure out the how many degrees, the different types of degrees in the entire population. So what we do is we split them up into small groups, and those are called strata groups. Okay, so it's a group of a larger population. What we do is we end up setting up a proportion um, using the total number of people, and then like say for example, we stratified it to 250. We use like this data here. We would make up like we have 155. I'm sorry, 1,575 AA degrees, 1,575 AA degrees over. What you do here is you add all these up, 1575, 565, 415, you get a total population 2555. And we want to make it a smaller group. Well, they decided they're going to make they stratify it to 250. So they would take the number of degrees, here in this case, AA, out of the total, and they would set up a proportion, trying to figure out how many of those people of the 250 have an AA degree. And when they solve that proportion, they get 154 out of 250 um, have an AA degree. And that's what this example is showing. So basically, we're going to take data from a huge population, maybe set up different strata. We're going to stratify it to um, different groups, divide it into different groups, and then figure out what percentages, okay, or how many people. Number two, paper companies has been reducing the size of its paper towel rolls in an effort to adjust rising costs by keeping the price the same but providing less of the product. The company can recoup the increase in cost to manufacture paper towels without customers paying per roll. Before the size reduction, 138 sheets of paper towels cost $3. What is the cost per sheet? Now, one thing I'm going to do here is I'm going to change my dollars to cents because I know that a sheet of paper towel is not going to cost $1. I don't want to be dealing with fractions or decimals. So I'm going to take this $3 right off the bat. I'm going to make that 300 cents. Okay. Just because I don't want to work with decimals and fractions. So it says before the size reduction, I'm going to blow this up a little bit more. 138 sheets of paper towels cost 300 cents. So 138 sheets of paper towels per 300 cents. So if I make a unit, single unit of measure here, I'm going to take my 138 sheets of paper towels. I'm going to divide it by 300 cents. This will give me number of paper towels per cent. So I get like 0.46 sheets of paper. I'm just going to put sheet per 1 cent. Okay. Now, if the CEO of the company still wants to charge $3 for the roll, how many sheets need to be in the roll to bring the price per sheet to 3 cents per sheet? Okay, so we still have our 138 sheets that cost 300 cents. And now we don't know how many sheets. When you're setting up proportions, always make sure that your labels stay the same. So how many sheets we don't know get 3 cents. Okay, we all remember how to solve these. Cross multiply, it's called actually cross products. 3 times 138 equals x times 300. Okay, 3 times 138. 414 equals 300x. And then we want to divide by the coefficient 300. And we get 1.38 equals x. Okay, so it's how many sheets? So 1.38 sheets per x. Is this a significant difference in the number of sheets? Determine the percent change. Oh, I did this a little bit. Instead of sheets per cent, I need cent per sheet. So instead of taking 138 divided by 300, I should have taken 300 cents divided by 138 sheets. Give me the cost per sheet. So 300 divided by 138 gives me 2.17 sheets per cent. Okay, so for 3 cents, you get 1.38. Then I'm going to have to multiply that by 3. So 2.217, I'm going to multiply by 3. So I get 6 0.52 sheets per 3 cents. Just want to make sure I'm comparing apples to apples here. And here I'm getting 1.838 per sheet. So that's a significant difference of how many sheets you get um, when you charge per sheet. So the difference between 217 and 3 cents, let's see, difference between, they want us to find the percent. So what percent equals a change of, okay, so they want us to find the difference between what is the percentage difference between the increase in price. So we want to find the percentage, which is X. There's a old formula out there. It says X over percent. I'm sorry, X percent over 100 equals the difference of the old and the new divided by the original. So the percent, we don't know, X over this one, they want us to find out, over 100 equals the difference. Now the difference was, let's see, 3 cents and 1 cent. Okay, so the difference between the new and the old, let's see, the new is 138 and the old was 217. So 217 minus 138, I get 0.79 divided by the original, which was 217. Cross multiply and solve. So I get 79, which is 100 times 0.79 equals 2.17x. Divide by 2.17, divide by 2.17, and the increase is 36.4% increase. So oh, I'm glad you weren't able to see any of that. So again, I used my formula to find the percentage. I put the X in for percentage, X over 100 equals the difference between the old and the new. So I took 217, subtracted 138 to get 0.79, divided by the old or the original, which was 217. I cross multiplied and got X equals 36.4, which is 36.4%. Okay, we can refine how we solve proportions when the ratios are not easily scaled up and down, such as this proportion, x over 8 equals 1217. Notice that this proportion is true. 2/3 equals 8/12. Well, they're just multiplying the top and the bottom by 4. Diagonally across from each of the 3 and the 8, for each of these pairs of numbers, they're just telling us the cross multiplication is a method of solving proportions. And we all know that. Okay. Number 3, solve. Now, be careful. Remember from Algebra 1, whenever you have two terms in the numerator or denominator, put parentheses around them. Okay. Cross multiply. -3 times x minus 1 equals 5 times x plus 1, and then solve for x. Distribute negative 3x plus 3, negative 3 times negative 1 is 3. 5 times x, 5x, 5 times 1 is 5. I'm going to add 3x just because I like my variables positive. So I get 3 equals 8x plus 5. Subtract 5. And I get negative 2 equals 8x. Divide both sides by the coefficient 8. Now, negative 2/8 is the same thing. We reduce it as negative 1/4. Okay. Here's the whole process of how to set up a proportion that we did in the previous example. I'm not going to go through it. You can read it. Keep it handy. Okay. Ben and his roommates order pizza and Chinese takeout food for dinner. Ben tips the driver $5 for a $21 pizza. So here's a ratio. Ratio is just a fraction. $5, that's a tip for $21 pizza. How much should he tip the driver who delivers the Chinese food? So instead of pizza, I'll just put food so that they match. How much of a tip for pizza food, and then of a $34 Chinese food. Okay, cross multiplying south. 5 times 34 equals 21x. 5 times 24. See, 5 times 5 times 20, 34. It's 170. Divide both sides by 21. So he should tip the guy that delivers Chinese food $8.10. Okay, next one. Let's see, apportioning whole number quantities according to certain ground rules has long been a part of determining seats in the U.S. The Constitution states the number of representatives will be determined based on states' respective number, meaning its population. All right. Currently, no more than 35 seats total, according to 2010 census. United States has a total population of 309,183,463 million. So they want to know how many numbers in the seats of the House. So for Florida, let's see, they have 18,900,773 out of 309, 183, 463, and they want to know how many seats they get out of 435. So cross multiply and solve. No, I'm not going to write all this out. I'm going to do this in the calculator. Let's see. 18,900,773 times 435. Hit enter. Then I'm going to divide that by 309. 183, 463. Uh-oh, something happened in my calculator. See, I'm going to take this and divide it by 309, 183. Okay, so they get 26.59 seats. By the way, this isn't actually how they do the determine the seats in the House. Okay, Ohio, 11,568, 495 out of 309, 183, 463. Same thing. X out of 435. If I cross multiply, I multiply these two together and divide it by that. So, let's see, 11,568 5 times 435 divided by, multiply these, divide by that. 3, 463. And I get 16.28. And the last one, I'm going to take my 25, 268, 418, multiply it by 435, divided by 309, 183, and I get 35.35. That's it. This explains that they really don't use this method to find the seats else. That's it for section 2.14.